Missed. AI is in the air.
All right, hello and welcome to Watson for Wireless. So my name is Mary Kate Burnell, and I do marketing here at Mist. I'm also here with Bob, Randy, and Pedro. To get started, why don't you guys just go ahead and introduce yourselves and tell us a little bit about what you do.
Yeah, so Bob Friday, I'm the co-founder and CTO of Mist and focus on making great wireless experiences.
Randy Fry, Chief Architect at Mist. I oversee our technology. I've been doing wireless and networking most of my career.
I'm Pedro Alves, founder and CEO of Opal, and the goal is to help AI deliver on its promises.
All right, great. So I think the question that everybody's wondering is, first of all, is AI just a buzzword? I'm starting to get worried that AI technology is going to show up on my shampoo bottle or my coffee mug. Everyone's using it. Is it just a buzz, or do you think it's something that's really coming to be?
Yeah, I know. So I listen to these podcasts on the way to work and everything, and I was listening to Miko Cook, who's a famous physicist, and he's saying AI is going to be on par with steam engines and transistors. And I tend to agree with him that when you look at what AI is doing for us, it's basically there's going to be winners and losers in this transition. And if you look at what AI technology is doing in the job market, it's clear that repetitive jobs, middleman jobs, things that basically slow down capitalism, we're going to see those jobs disappear. And so I think we're going to see AI actually, kind of be on par with our transistor and steam engine, and it's going to be revolutionizing all aspects of our industry.
So you think it's defining our generation?
I think this generation, I think AI is going to be up there with the car and the plane.
All right, Randy, what do you think?
Yeah, it's there already. We don't even know it's there sometimes. I can't imagine doing driving directions without Google Maps. It used to be I'd check the traffic maybe a couple years ago to see where the traffic was and try to avoid it. Now I put my trust in their real-time driving directions. Same thing with YouTube recommendations. I actually had to tell my daughter the other day to stop messing up my machine learning recommendation engine. She was watching cartoons. Now I have a bunch of cartoons recommended for me, so it's indispensable. So it's really in there. Neither of those platforms have marketed AI to me, but I'm using it and I can't live without it now.
All right, Pedro, what do you think? Buzzword or defining our generation?
Yeah, definitely defining our generation. It's close to that tipping point of delivering as much as it can. I think we're just short of that. On the technology side, I think what I'm waiting to see is the same kind of ingenuity that we saw with other inventions like the car or the airplane, where they're inspired by nature, which is flying and traveling fast. They're not mimicking nature, right? So you see the car doesn't have legs, it has wheels, and it outperforms the cheetah, and same thing with the planes. They don't flap their wings, but they fly faster than any bird. And with deep learning, we're seeing still the idea of mimicking the brain, which is fine, but the brain was not optimized to do any of these tasks solely that we're doing today, right? It had so many constraints in evolution that I'm sure if we wanted to and completely thought outside the box, we could engineer something that is way more efficient than the brain at a specific task.
So where are we now? Are we at Terminator, or are we, at like a chat box?
We're getting to the chat box.
What do you think, Bob?
Yeah, I think right now, if you look where we're at, you look at Alan Turing's definition of AI, right? That was the original definition of 1950. Can you put something behind a screen, ask questions, and can you really tell the difference between a human? If you look what the Watson team at IBM did for Jeopardy, I think we're at that point now. I think you'd have a very hard time telling the difference between Watson playing Jeopardy and the actual human. So I think we're at a very key point where AI is actually starting to make a difference in a lot of it, as Randy mentioned.
And why now? Why is now the time that it's making a difference?
I think the compute power is one. I mean, if you look at Moore's Law came out in 1975. I think there's about 20 years left in Moore's Law that we're basically doubling compute power every year or so. We're seeing now that, that compute power has gotten to a point where we can actually do interesting things with the technology. 20 years ago when I did my master's on AI, I built in the neural network, and you couldn't do anything interesting. Now we've got to the critical mass where you can do image recognition, right? You can actually do something interesting with the technology. And I think if you look what's happening in the VC world, I've gone to like 3 VC dinners in the last month or so around AI. We're starting to see actual quantum computing startups getting funding. So I think the compute power has got to that critical mass, and we're only going to see that increase more and more over the years.
You actually are going to a VC now after this, are you not?
Yeah. They are all over AI.
Absolutely. Okay. What else? There's got to be something else, right? Why now?
Yeah, so you don't do AI without data. You need a lot of data to do AI effectively. Big data was the last big buzzword, a big trend, and big data was real. Now we have the data. You don't process the data without compute power. Now we have the cloud. We have AWS. We have a lot of cloud compute that we can throw at it. And now we have the algorithms. We use a lot of algorithms that are very similar to my friends at PayPal and other companies use. It's the same algorithms, the same artificial intelligence applied to a different domain. So we have the data, we have the compute power, and we have the software and algorithms. So it's all come together.
And what about open sourcing? Does that have anything to do with it?
Yeah, massive open source. Just like all industries in networking the last 10, 20 years have gone and leveraged open source. Linux 20 years ago, 15 years ago for embedded operating systems. The trend has been there for a long time now. Open source is highly leveraged. Now we have to adapt it for our particular domain expertise, but that's what we do. We adapt it for our domain, but we leverage open source heavily.
Okay, so I want to talk about that, your domain specific. I want you to tell me what are the different industries that are using AI right now, and then why wireless?
So, I mean, I guess in the wireless space, I mean, we know AI is making a difference in Alexa at our home and our Teslas and our self-driving cars. I think if you look at the CIOs in our enterprise businesses, they're really dealing with kind of two big macro trends. One is they're starting to see their workforce go all mobile, right? You know, we're all moving to access. I think it's clear that the days of the wired network, the wired connectivity is going. We're all wireless now. The other thing that we're starting to see global, right? You know, my day does not end at 5 o'clock anymore. The workforce is global. So we have this very mobile global workforce that CIOs are having to deal with in the enterprise. We're also seeing inside of their enterprises right now, they're actually moving from where I was 15 years ago when I did aerospace. There it was all about trying to help enterprise CEOs with their employees and all about connectivity. Now we're seeing with their workforce, with the worker and the consumer gray, you know, it's hard to tell the difference between when you're working and when you're consuming, right? Because on your mobile device, it's all one same thing. So now the CIO really is in the business having to start to deliver more critical services on top of his own wireless network. And that's all around delivering wayfinding to either consumers or really trying to do more operational efficiency things inside of his own business, right? Facilities management. You know, so we're really in this time helping the CIO really become a service provider, providing services either to consumers or employees inside of their business.
So I'm hearing two things. I'm hearing that they need some visibility into what's going on inside, and also that it's starting to reach outside of the business where people are coming in the door and you're trying to support them.
Right. And if you think about it, you know, back to the original discussion, you know, AI is really going to do away with a lot of these middleman jobs, right? And so CIOs are really looking to AI to really making their IT staff more efficient and to provide them quicker insights quicker, right? You know, they have massive amounts of data going on, as Randy mentioned. You know, they're trying to extract that data from their networks right now and apply it in real time to some problem they're trying to solve.
Yeah, now wireless is getting complex. You used to be at a router, you have an access point, you have a DHCP server, and you give someone the password, and one of those things will fail, and that's going to be your problems. You would rely on people calling in to complain. Now you have a lot of different applications and services. You have IoT adding to the mix. Who's going to call up and complain when a point-of-sale device doesn't work? So now applying AI to there, we can look at all those different dimensions and figure out root causes and issues when problems do occur without relying on somebody calling up to say they can't access the internet.
I think, what services do you use right now that are on the cloud outside of wireless?
As an individual or as a company?
I mean, we're saying they're blending together, right? So both.
I think infrastructure for any project that I'm doing, right? Whether it's compute or data storage, I think both. But then your whole personal life is up there. So.
Oh, it is up there. Your Gmail or whatever it is there.
I mean, I could probably give you a good example. You know, we're working with several customers, what I call kind of the B2C industry. You know, and it's kind of like when you know, Google Maps has become kind of standard, right? I mean, everybody here uses Google Maps to find their way from A to B. You know, what we're starting to see is that want to move indoors too, right? You want to continue that consumer experience when you move from your home to your workplace or to your hotel or to your mall. You want to continue that into your workspace, right? I want to find the conference room I'm going to. You know, so that's the kind of the blending of, you know, using your consumer technology also to start to solve your workday problems.
Okay, so if wireless is going to be one of the last men standing here, what do you need to have an AI-driven WLAN?
You know, if you look what we're building at Mist here, right? You know, we're in the mission right now to build a virtual wireless assistant. You know, and building that, it starts with data. You know, my analogy is I make wine on the site. You can't make great wine without great grapes. Same thing with virtual AI assistants. You cannot solve AI problems unless you have great data. So it starts making sure you have the data you need to solve the problem. The other thing is, you know, compared to other industries where you have unstructured data, this is really applying domain expertise, right? Once you have that data, you really want to put labels on it. You know, and here at Mist, what we're working on is, you know, what we call SLE metrics and classifiers. So we take this data from the edge and actually label it and sort it and everything. And that really becomes the input to our algorithms, right? That's the input some domain expert could actually make sense of. And that's what we're using into our data science toolbox. You know, and that's where we're working with people like Pedro who are really helping us build that data science toolbox we need to process that data. And then on top of that is putting the face. You know, this is where, you know, you want to put that Watson for Jeopardy. You need to have the interface that actually makes it easy for the IT and CIO managers to actually use.
And how did you come into the mix, Pedro?
Yeah, I mean, the way I see it is allowing companies to make use of these technologies without having to hire teams that are almost impossible to find. So working with Mist and giving them the opportunity to very easily use deep learning, and then as a result get more accurate models and much shorter turnaround times for these projects, right? Which means with the same team and without having to grow that team, getting better outcomes and more projects per year, which touches on the key point of my personal belief is that the value a data scientist brings to a company is not tuning parameters and choosing algorithms. And we're taking that over and allowing people at Mist to do what is most valuable, which is thinking how else can we use this data, how can we apply AI to it, and how to formulate these problems, and not just tuning parameters, right? That's the real value data scientist brings.
And Randy, you can probably speak to this. I mean, what are you building with it, right? You decided you're going to put AI into wireless. What are you building? How do you use it?
So we're building better wireless. Part of that is things like recommendation engines. We look at the data from a network and we look at it from the user's perspective, not the network's perspective. We see if the users are happy or not, whether they're able to roam fast or for their voice calls, whether they can get the throughput that they need, and we analyze all the data in real time, and then we make recommendations. Add more access points, change frequencies, so the IT team can then go and use those to improve their wireless experience for the customers. And we'll also fix things as they pop up. If we have to change channels to increase capacity, the system can automatically do that.
And where do you get the data from?
We get the data from the access points. So one thing about AI, as I mentioned before, data is very important. Not only do you need a lot of data, you need high quality data. If the data is junk, you'll get junk recommendations. So we produce an access point so we can treat that as a sensor to grab the exact data we need. As our algorithms process that data and we discover new things that we want to know, we can very quickly treat that access point as an extension of our cloud and push down new software and data sources to it and get that data back in real time. So we have a very fast innovation velocity there for our AI.
I want to take a little bit into the architecture. You know, you mentioned upgrades. How quickly are you able to push those out?
So we push out upgrades all the time. We can download software in real time to the devices. So we have a very tight cycle time for pushing out sort of firmware changes. Sometimes we actually push out new data definitions to create new data in real time. So we can go within a day. We can discover something new in our data science lab that we want to then uncover new insights, realize we need a new data source. Within a day, we can have code out there on the access points providing us that data.
I think I'd add to Randy, right? This is really a distinction between moving from kind of an embedded software architecture to these distributed software architectures, right? And this is really trying to bring the innovation of the cloud speed, right? You know, when you move to these distributed software architectures that are based on APIs, it really does let you move at a much quicker pace on your software development. You know, where we actually can do releases almost on a weekly basis now as opposed to a yearly basis.
Mm-hmm. And we're actually incorporating machine learning in our actual firmware quality. So when we push out new firmware, traditionally you'd wait for customers to complain if there's any issues. That might take days or weeks. It's hard to even determine how big of an impact that is. we push out new firmware gradually on different levels of systems, some internal then external, on a very slow basis within, say, a day, and incrementally push it out. And then as we gather feedback about the quality of that, we push out more aggressively. All machine learning, the entire process.
So let's dive into that a little bit. So domain-specific metrics, I think, are a second pillar, right? So Bob, do you want to speak to those a bit? What can you really do with them?
Yeah, so I mean, domain-specific, that's what we call domain-specific SLE metrics, is really around putting labels on this data, right? So we're getting data from the edge of the network, from our endpoints, from our access points, and this is really putting that data into terms that a domain expert can understand. So when you look at a missed solution, you'll find time to connect, roaming, coverage, throughput, AP uptime. These are metrics that a wireless IT guy could actually understand. Those are the key points of now feeding into our data science algorithms. Because you look at the problems of most wireless IT, I usually put on par with like doctors and cancer, right? If you look at a doctor, cancer patient comes in, gives you some very vague symptoms, and then doctor is faced with the problem of sorting through tons of data to try to get to an answer. Similarly, in the wireless space, wireless IT guys are faced with the same problem, right? You usually get very vague symptoms that you're trying to understand. Then you have petabytes
can't connect.
You can't connect. Someone comes up. You get those.
Slow.
Yeah, you get those calls every day now. But this is the same problem wireless IT guys really get. And they have log files they have to deal with. So taking those metrics is basically taking those log files and organizing in such a way that now we have the data into structure we understand, and actually help the IT guy get to the problem area quicker.
Okay, and Brandy, I mean, you work a lot with the root cause analysis to talk about that and how that plays a part.
Yeah, so one thing that our root cause analysis will do is not only determine a problem that individual user is having, it also determines the impact of it. Often one person having a problem could imply that a lot of people are having a problem. So our AI looks through the data and correlates it with other network-wide issues. So an individual user having a problem calling in, it'll actually tell then the IT staff that it might be an outage that's affecting dozens of people or hundreds of people.
Yeah, so a good example, following up with Randy, is kind of like we had one customer where they have basically disabled all the lower data rates on their access points, in theory that, they were going to try to bring up the average speed for everybody. When they did that, all of a sudden their time to connect metric went way out of whack, And there was, logical person would have no way of knowing that. It's like, why would lowering the data, turning the data rates off affect your time to connect? It turned out there was a weird correlation between their DHCP servers and losing those lower data rates. With this system now, that insight was automatically correlated, right? We were able to detect that the metric had gone down. Our anomaly feature discovery caught that and was able to correlate it with this actual event. It would have taken a normal IT guy probably days of hours to ever define that, to try to make that correlation. Now, with all the software and this virtual assistant right in the background, it can bring it to the forefront very quickly.
All right, so this is kind of a silly question, but what is the coolest thing about it? I mean, you guys are working in machine learning all day long. What do you find that our customers are really excited about?
I think, some of our big customers right now is usually, we had one customer, they'd had some problem for 6 months. They were doing barcode readers or something. They had never figured out why this barcode reader was causing such a problem. They put our system in place, and within a couple hours, I think they finally figured out what was going on with this barcode reader, right? Because we were able to go through that data and automatically figure out the feature that was actually related to the problem and bring that to the forefront.
What was the problem?
It was some sort of 802.11, I forget what the exact name is, an 802.11 spec. It was a device who wasn't really obeying the 802.11 protocol. And it really didn't show up until we actually correlated to some of the DHCP server reactions were happening, right? So that's a funny interaction where 802.11 has a problem, and it's really causes your DHCP server to have a problem.
And it's interesting, too, because people do have all these different devices, right? I mean, just sitting at my desk, right, there's an iPad and a watch and phone and everything else, and they're all interacting differently.
Yeah, and that's what Randy's saying, right? This mobile world is getting much more complex. More people are trying to put more and more services on it beyond just connectivity, right? We're starting to see much more indoor location services on it. We're starting to see BLE become more relevant. BLE is, BLE and Wi-Fi are converging. So this is where you actually...
And maybe for the if they don't know what BLE is.
Oh yeah, no. So BLE is a new wireless technology. So this is basically Google and Apple put in new BLE beacon technology into all your mobile devices. Very similar to 15 years ago when we saw Intel put Wi-Fi into our laptops. What we're seeing now is we're watching Google and Apple put BLE into our mobile device technologies. And it's really around, that's the proximity location technology of choice now for mobile devices. And so we're helping CIOs really not deal with that convergence, right, as they try to leverage that technology to provide new experiences to consumers and employees in their venues and their businesses.
Okay, so we've got the data. We've got the data labeled in a way that's meaningful. What's next?
I think the next thing is the data science toolbox. This is where we really are working on trying to help bring those correlations to that. And so when you look in the data science toolbox, this is where Pedro's helping us make that toolbox bigger. You'll find things like anomaly feature discovery. These are basically tools that allow you to quickly go through tons of data. And for every data point you have, you may have 30 or 40 features associated with that data point. What I really want to know is which one of those features is relative to causing me pain. Is it my iOS device? Is it some AP? Is it some gateway? So there are algorithms that let you quickly start to figure that out. There's other algorithms in there like real-time series anomaly detection, right? These are algorithms that look for anomalies, and then you can correlate those. So that's back to my example, right? Find anomalies and then correlate it to other events, so you can quickly figure out, what configuration change actually was related to that problem.
I heard someone say a few days ago that can also be used as root cause to innocence. You think that there's a problem, everyone's upgrading to something, and you go in there and you find out, nope, it's not that, or no, it's not the network.
I think most IT guys know that, probably 80% of their problems are caused by someone on their team that misconfigured something, right? A lot of these problems are misconfiguration problems that happen innocently when you don't think you're, through your data rate problem, right? No one would have thought that shutting down the data rate should cause a time to connect problem.
Right. I mean, what do you think? You're helping them create all of this?
I think they're in a strong position given the amount of data that they have, and Bob just brought up a good point, which is it's not just having a good model that predicts well, it's having a model that you can understand why it's doing what it's doing. There's been a lot of cases in the literature showing that models that have performed well in data sets were making decisions based on things that were not meaningful. And so that is very important. That's something that we put in our algorithms, which is an explanation of this is why the model is making these decisions, so that a human being that understands the field can feel comfortable about having that model in production.
And is that more about when you're in there from your day-to-day making changes, or is that also about business applications?
I think that applies to both business application and day-to-day changes. To Randy's point, we were actually even using machine learning algorithms to look at our firmware updates, right? So even on the back end, and this is why as CIOs move to managed cloud services, what they're really doing, they're transferring their IT team, they're transferring some of the part of the business to a problem where that are not important to their business, right? And this is what they did with Salesforce.com, right? They moved Salesforce, the maintenance of it, to the cloud, so their teams can really focus on what's important to their business. Same with wireless, right? We're watching the teams move the maintenance of the cloud over to NIST, so we can take care of the hard wireless problems. And they're really focused on getting the data they want out of that network now that's really relevant to their business.
That makes sense. And since you mentioned teams, let's talk about those IT teams. What is the IT team of the future? I mean, if you don't move to the cloud, you don't start using AI, we're afraid that people are going to get left behind, but this is not necessarily the case, right? You can harness the power of this.
Yeah, no, I think, at a macro level, I think people are seeing AI technologies, or like I said, are going to replace those repetitive jobs or minimum jobs. And really, the IT team of the future is going to be much more focused on data and programming, and actually doing some of the data. So I think we're going to watch IT teams actually transform from, or not transform, but complement, right? We're going to see the addition to actually maintaining and running boxes to actually starting to leverage the data they can get out of the network.
And are there specific skill sets that you recommend that people look at? Randy?
We are seeing a lot more programming in IT teams now, so they can access our data via APIs and run with the data on their own and not just click on a graphical user interface. One trend we see in the programming world is people moving from procedural programming, telling the computer what to do, to descriptive, telling the computer the intended results. We've seen that trend now also in the IT teams where they want to describe the intent of the network. They don't want to say, I want to configure this router with this WLAN. They want to describe the intent. They want a certain coverage, they want a certain capacity, and a certain roaming time. So with our system, they define their intent of the network, and then our SLEs and AI then measure to see whether that intent was made, and when it's not made, what to do to improve it so that their intent at the end of the day, which is to provide coverage to the users and capacity, is made.
And I think that's our fourth pillar, right? You have to put a face on it. It's a virtual assistant, essentially.
Yeah, no, on the journey of building this, at Mist here, we're working on this virtual wireless assistant, right? We're getting to the point where, as Alan Turing would say, you should not be able to tell the difference who's behind that screen, whether it's a real person or a virtual person. We're putting that face on it now so we can actually start to present this data in kind of a natural language format back to the IT teams, right? And then we should be able to explain them with some level of confidence, that we think your root cause is going to be coverage due to weak area or due to something in the infrastructure, and provide them actually a pointer to what we think the resolution is going to be.
All right, so I'm going to put you guys on the spot here just a little bit. We want to make sure that we've got some questions from the audience to kind of make this a little engaging. So if everyone wants to go ahead and put some questions into the question box, and we'll start to get an answer to those. And I've got Jeff back here who can start to feed them our way. We'll take a couple now, and then we can continue our discussion.
Sure. One that came in is, what is the difference between AI and machine learning?
Yeah, for me, AI is really the is back to that Alan Turing definition. AI is putting a face on machine learning and the algorithms underneath it. So when you actually, interact with a system, an AI system, it should look and feel more like a human, right? So to me, AI is the interface on top of it. When you use your Alexa at home, right, it's starting to feel and look like a human because it's starting to answer questions. The underlying technology behind that is voice recognition, right? Somewhere behind that is a neural network or some machine learning algorithms that's recognizing your voice. But ultimately, from your perspective, AI is actually the interface on which that technology is delivered to you.
I think you wanted to jump right in there. Go ahead.
Yeah, not very different. In my mind, more about just if you think about the terminology, right, artificial intelligence, it's not really an algorithm, it's just something that's mimicking intelligence, whether that is recognizing something in a picture, playing chess, having a conversation with you, anything that mimics something that you consider you need an intelligent being to do. Machine learning is a collection of algorithms that people use to achieve artificial intelligence. You can achieve artificial intelligence without machine learning, right? With simpler methods, heuristics and rules, they're not going to be as intelligent, but you see what I mean? So it's a bigger spectrum of artificial intelligence, and machine learning is probably the strongest tool to achieve artificial intelligence. And within machine learning, deep learning being the strongest right now of the tools within machine learning.
Okay, so quickly, what is deep learning? You define it for people.
It's one of the many algorithms in machine learning. It's the hottest one right now. I think it gained this much popularity because of the advancements it made in image and object recognition. It was where it really was shining bright, and that is a big problem, so it became this big name.
Yeah, I may add this to give, make it more real. So, at Mist right now, in our indoor location product, we actually do machine learning where we actually learn the path loss model, right, for doing these location estimations. So there it's actually an unsupervised machine learning algorithm that actually takes all the RSSIs it hears from these beacons coming down to the mobile device and then determines the actual relationship between RSSI and distance. So that's an actual machine learning algorithm that's doing that. From an AI perspective, though, there's no sense of that. From there you have to take that information and now turn it into something that someone will consider AI, right? And then that's about where am I located, right? And giving it a face where, yes, I can now tell you where you're located, and I can help tell you whether or not your friends are near you. That begins to become more of an AI experience.
Okay, and Pedro, maybe you can take it a little further. That's where we are now. Where are we going with AI?
The most honest answer.
Question, I know.
Yeah, I think the part that I'm excited about is that my answer is I don't know.
Okay.
What I'm excited about is that, if you look back at the telephone, the airplane, the computer, when those things were new, even the people in the know, the people that knew those technologies, their predictions of the usability and the ways that the world was going to benefit from these things were so small compared to how they actually impacted the world, right? Quotes about, there's going to be 10 computers in the whole world, and that's about it. And so I think that's where we are with AI now, because we didn't start to see the possibilities for those things until they became cheap, easy, and ubiquitous. Now, go ask a company and a product manager out there if they think AI is cheap, easy, and ubiquitous, and it's not. So the next 3 to 5 years is going to be turning AI into something that's cheap, easy, and ubiquitous, which is one of the things I'm doing with Opal. After that becomes a reality, really is when our minds are going to start being imaginative about what didn't we even think about doing with AI, and then that's really going to start getting exciting.
So what is your big plan, Bob?
Yeah, I think, the plan here at MIST is really getting this virtual assistant. As I said, the point is really to help AI teams and CIOs basically focus on their business and their investments. Our vision is we should be able to build our own virtual assistant that really allows them to get to root cause quicker. So when they're actually providing services on these wireless networks, that, when someone calls up, we should know that that problem's already hit. So, my classic case is hotels, right? If someone's at a hotel, they have the right, the front desk should know that guest is having a problem before they even call down. You want to be proactive, you want to be able to preemptive. I see AI getting to that space here in the next couple of years, where we will be able to go through petabytes of data, that used to take IT guys or humans hours or if not days to go through. That will be done in minutes, and that's what computers are really good for, right? And that's what the Watson team proved on kind of Jeopardy, right? That we can go through megabytes, petabytes of data very quickly and get to answers very quickly, as opposed to what a human can do.
Very good. All right, any other questions back there?
Yeah, several. So does AI require new skills in IT? For example, does a wireless LAN admin need to learn programming to make sense of all the data generated by AI?
I think, it's going to require new skill sets. I think IT times, yes. I think the IT teams of the future are going to want to be more programming. They're going to be able to look and use data more often. I've worked with Pedro quite a bit here. It's not that AI is going to eliminate the need for data scientists. It's really going to make their jobs quicker and easier. I think the same is going to be true in IT. You're going to want an IT team that really understands the business data in addition to the technology, that starts to really understand the data and how that data affects their business.
Yeah. And Randy, I'm sure you've seen that, right? That's why we have all of these root cause metrics. You took a clean sheet of paper. What do you want to do with AI and wireless? The first thing that everyone says is make it easier to manage, right?
Mm-hmm. Yeah, to solve their problems, make it easier to solve problems. Once we have more AI, though, in the future, I think it starts allowing us to add services on top of the system, not just solve problems, but add additional services such as location, indoor location. So we use the same AI techniques and machine learning, as Bob mentioned, to start allowing people to do indoor wayfinding, zone analytics, to understand their users as they move throughout a building. As both building on top of the AI that we've already developed for the Wi-Fi.
That's really interesting. All right, Jeff?
Are special access points required to leverage AI, and can AI be used outdoors?
2-for-1 question there. So how's the first one? Can it be used?
Yes, I think the quality of the data is very important. So it's not necessarily a special access point. It's not different hardware, it's different software on that access point. That's absolutely critical. You just can't get this data out of syslog files. It can be totally used outdoors. No reason why it cannot be used outdoors just as well as indoors, but it definitely requires different software on the access point. When we developed our access point, we didn't just create our own hardware, design and run open source OpenWRT on it. We rolled our own Linux, we rolled all of our own software for especially low-level state machines, so we could gather the data for client activity that we needed.
Yeah, so to answer your question, back, the AI does not require special keys or special hardware aids. The reason I decided to actually build access points here and actually build hardware is I want to make sure I had control of the complete solution experience from end to end. But that does not necessarily mean I need to actually build hardware.
It's actually the architecture is different. So the hardware fits into the architecture where we collect the data, send it to the back end. We use a different software architecture there on the AP, but it's really fitting into the overall cloud architecture.
And probably, one of the big, one of the subtle differences on the AP side is that software on the AP side is historically almost all access points actually send data back every so often, right? That's been around for a while. What we're doing here on the software side is we actually have event-based software on those APs, right? Which really sends asynchronous events. So those are basically the user state, right? So that experience is being sent back on an asynchronous basis in addition to synchronous data that's being sent back every couple seconds.
And does that have any impact on the bandwidth or anything, or it's...
It doesn't have really impact on the bandwidth, but it gives us a better visibility on actually what's going on to the end user. Because I think one of the big changes we've seen over the last 15 years, right? When I did my last company, which was aerospace, there it was really about helping CIOs manage access points. In this transition, as we mentioned, it's really about services, right? At MIST, we're really focused on trying to help the end-to-end experience, right? We're trying to help the CIOs manage the end user experience all the way to the back end, not just trying to help them manage some access points.
Yeah, actually, you can have a positive impact on the bandwidth. Instead of just sending all the data back to the back end, all the received bytes and signal levels all the time, which has been done for decades, we have intelligent probes sitting down in the access point to watch for certain things, watch for failures of state machines. Then we send up just that data in real time as it happens.
That's incredible. And how many state machines are we looking at? Do you have to constantly tell it which ones to look for, or does it kind of put it on its own?
We tell it what to look for. We have software on there to specifically tell it to look for certain events, and then our backend system will learn trends based on that data.
Yeah. So you really mean this because we've broken the user experience up into kind of states. There's kind of your pre-connection state. And this is where people really have not done a good job in the past, is really trying to understand, are people, what does it really take to get someone connected to the network? You look at Wi-Fi, that's really been a function of, Wi-Fi mobile devices are really got a much lower barrier. Cellular devices, the cell guys keep all those mobile devices at a very high level, and they have very high bars for them to interoperate on the network. Wi-Fi, we've got WFA. And so we're dealing with devices that really were designed for consumer type of experiences, not for enterprise experiences.
All right, Jeff, what's the next one?
How do IT vendors like MIST keep all the data they collect secure and private?
You just
Randy,
this is fresh in your mind right now, right?
Yes. A whole other industry that's been around for decades, encryption. So we take the data, we encrypt it, we remove any personal identifying information. Very often that's not what our customers are at anyway. They're not looking for the people's identity. They're looking for trends so that they can make their system better. So we anonymize data. We use a lot of metadata. It's a term we use a lot. It's not the data itself we're looking at. It's the data around the data. How long did it take a user to connect? Maybe what operating system they're using, what type of device. Who the individual user was really doesn't matter to us. We will collect some data, though, in case somebody calls in and says, hi, I'm Bob and I'm having a problem, so they can be looked up in this system. In special case like that, the data is anonymized, it's encrypted, so only the IT vendor that owns that customer can see that data.
So how many security audits have you gone through lately?
Too many. Many, too many.
What about when people log into a guest portal? Are you able to collect information if you wanted to?
It's totally up to our customer. So our customer, the people that deploy it, can choose whether or not they want to collect their customer's data. So if somebody at a library connects to a library network, whoever installed our equipment at the library can choose whether or not they want to collect the data. They can actually even choose, if we do a social login where we talk to Facebook or Google to get authorization for that user, they can even choose where we won't even ask Google for that information at all. Not that we don't store it, we don't even ask.
I think it's fair to say, Randy, right? I think we've gone through several security audits lately where I would say with this architecture here, we've actually cleared the security audits where the legacy vendors really haven't cleared the security. We've had a couple of cases where we got through the security audit and our legacy competition didn't get through it. So I think, the other thing is this cleaner architecture actually is probably more secure than what you've seen in the past.
All right, Jeff?
Okay, paraphrasing this one a little bit, but how is AI used to determine exact location coordinates?
Yeah, so on the indoor location space, what I've done, 15 years ago, when I was doing Wi-Fi location, I tried to do that. I didn't have the compute power. And this is really around the path loss model. So when we're doing RSSI-based location, one of the things you have to determine is really this path loss model that gives you the linear relation between RSSI and distance. Typically, that has been done with site surveys. Typically, people will go around, they measure a bunch of data, and they actually try to figure out what that PLF and that path loss model is. With enough compute power now, we actually use unsupervised machine learning algorithms that can actually take the RSSI data from the actual clients and determine that path loss model per device and per AP. Now, when you think about that, there's another whole long discussion of how did that really happen, and that's kind of the magic of unsupervised machine learning. With that, we can have a longer discussion, but yeah, it is magical that it can be done nowadays. 20 years ago, I tried it, and on a Linux, a little one of you Linux boxes really does not have compute power. Now with Amazon and everything, we have enough compute power where I'm not limited by what I can do.
Do you find that your accuracy is better as well because of it?
Oh yeah, no, it does two things. It provides much better accuracy. The more you get that model correct, the better the accuracy. It also provides more consistent experience across devices, right? Because your Android and your iPhone definitely will not be the same device. You'll find that these mobile devices aren't created equal. Some of them hear barely better than others.
Okay, Jeff?
Okay. How long before we see a true virtual wireless assistant? And as a use case, would the MIST virtual assistant be able to understand the application types such as voice video data and adjust QoS to ensure SLAs are met?
Yeah, and that's something we're working at payroll on right now. So on the question of when, I would say MIST, we are shipping Virtual Assistant 1.0 now. We're working very closely with payroll right now, what we call our throughput model. And this is really around trying to accurately estimate internet speed, right? And that's kind of the key to actually doing a good job of trying to figure out, is that connectivity experience going to be good enough for video, real-time video, voice, or internet? There, I think we are probably months away. We got the API up and running, and we're basically, and that's really around, as we talked about, getting the feature we need to actually train the model. So when we work with deep learning, it almost becomes more of a data collection process than it is really a modeling problem.
Mm-hmm. Yeah, exactly. The modeling problem goes away, and I think another interesting feedback that we've been working on back and forth is the idea of letting the model tell us how much more data it thinks it needs, right? So that you're not spending too much energy and resources and money on collecting more data, right? You don't want to overspend. That could be a very expensive endeavor.
And so this is back, how much data do I need to train the model, right? Is it one data point or a million? So we're, the answer is somewhere between 1 and a million. We think the answer is probably a couple thousand right now.
All right, what's next?
Okay, final question. So if folks have more, please submit them now. But can you multi-tenant the wireless network into multiple disparate companies? And can you correlate data to determine global trends across companies?
I think this is also looking at multiple sites as well.
Yeah, this is the, so by pushing all this data into the cloud right now, a good example is kind of on the location side right now. We have visibility across all these mobile devices right now, so I now know exactly how well the iPhone 7 works compared to iPhone 6, compared to the Android. So now we have global information on those path loss models for all these devices. Yeah, so there's a lot of cases now where we get benefit on training the data, where global data helps train the model better.
Yeah, the system's completely multi-tenant. All the data is stored at rest and in flight with tenant information, so it is a multi-tenant system. And we are able to use some data, such as operating system type, to make what we call global insights. We know whether Android or iOS, and down to the individual versions of the operating system, which one roams faster than the other. So that when one person has on their site a new device show up that they've never heard about before, that's never been on their system, we will have some indication already about that device and how its performance will be.
And it's multi-tenant, it's very hierarchical. So a lot of our customers are actually managed service providers themselves. So for us, we may have multiple managed service providers who themselves may have customers who may have customers. So with this system, we're able to basically provide, virtual companies, like you say, right? A managed service provider will actually take our system and actually offer it under their own name to multiple of their customers. So yeah, there's a lot of cases where the whole multi-tenant concept has been, taken to the limit. There is no limit. There's really no limit to how many levels of tenants we can have now.
Josh, do you have more questions?
Got one more that just came in.
Great.
Potentially two, but I haven't read the second one. Will MIST eliminate the need for active site surveys using third-party software?
I think MIST will, in the rural location site, will bestly assist that survey process. There are really two surveys we're talking about. There's kind of the classic Wi-Fi survey business. That business will keep going on as is, right? The business we're really talking about is on the location side, is how much surveying if we need for actually determining path loss models. That we're actually eliminating, the need to actually go out and actually determine those path loss models out in the real world.
And a follow-up is, can you export the data you collect via APIs or other mechanisms?
Yeah, absolutely. One thing we've done at other companies I've worked at, we've paired the UI person with the API person so that they can work very fast together and create a graphical user interface. We actually have an API-driven first system here at MIST where we define the APIs completely independent of the UI. The UI that we have is just one user of our APIs. We have a lot of API calls that don't have any counterpart in the UI. We also have customers that can bring up their entire network, not even ever touching our UI. So all of our data that the customer needs is exportable via API, and we've designed the system to be completely API-driven.
Yeah, because I think, we're working with a lot of customers who already have their own big AI teams. So we're really focused on really helping our customers get to the data they need.
Yeah, and I think it also, you can push in through the APIs too, correct?
Mm-hmm.
So when you're doing location, if you want to change your beacons, you can do so.
Yeah, we allow configuration of the APIs. We had a question a couple of days ago saying that can they configure 1,000 APs in 1 second? That was the use case. We said, sure, all via the API. Nobody's going to click that fast. So they can configure, they can set rules and parameters all via push.
Yeah, I mean, I think, to your point, I think, this technology is letting it virtualize a lot of things. On the BLE side, we virtualize the beacon functionality, right?
Right.
Basically, it'll take that battery beacon functionality and virtualize it. So once you put the system in place, you can put beacons anywhere inside of your venue and program those beacons as such. On the Wi-Fi side, we're doing similar things with personal wireless LANs. Once you have the Wi-Fi infrastructure, you can create now virtual personal LAN. Is your baby, right?
Yep.
The personal wireless LAN. Right, so that's another example of being able to create virtual wireless LANs on your infrastructure now, which is useful in college dorms, right, where people want to create their own little wireless networks for all their little wireless gadgets.
I love it, and I love the possibilities, right? You keep coming up with new things, but it's so easy to add on to the system. Okay.
Yeah, I mean, that's probably the other thing is, if you look at the services you build on top of this, this is kind of a natural services architecture. To be honest, when we started the business, I really wasn't planning to be in the BLE business. But the architecture was so flexible, when you looked at the problem, what they really wanted was a real-time services for locating. We actually had built a real-time architecture for doing that, for ingesting a lot of data. So it was easy for us to add that service without much effort.
Yep, and then once we added it, we realized location and Wi-Fi actually go well together. A lot of people's Wi-Fi experience is dependent upon their location in the building. So now we've combined them.
Okay, so I'm going to kind of ask you as one last question before we end. Jeff, that's everything we see? Okay, great. So if you could give one piece of advice to our audience about how they could get started in their AI strategy, what would that be? And Pedro, why don't we start with you?
Sure. The biggest, most difficult thing you're going to have to overcome is hiring, finding the right person. Mm-hmm. I think hopefully with the changes in the field, it's going to become easier because the requirements will be more reasonable. But let's assume you pass that point, you already have a team. I think communication. I've seen way too many times companies where the data science team is a little bit isolated, and the projects that they end up working on, even if from a science perspective they were successful, they achieve high accuracy, it's not matched well with the business the business outcome. So the company doesn't use those projects. They just get shelved because there's no impact to the bottom line. So better communication between the real business needs and making sure that the data science team is working on things that will matter and not just they're interesting and to play with the data. So.
All right, Randy, AI strategy, where would you start?
I would say play with it. It's accessible. Get a Python notebook on your laptop and just start playing with it. Extract out the data from an API, our API, anybody's API, load the data up, run Spark, different machine learning platforms, and just start playing with the data. It's a lot more accessible than people think. A lot of simple AI is statistics. I think a lot of people can easily grasp that and start playing with it and build up from there.
Right, and Bob, specifically, I already have a Wi-Fi network. How do I begin my AI strategy now?
Call Mist.
Well, that's a good one.
Yeah, so I would say, serious note, if you guys are really interested in bringing AI into your wireless strategy, feel free to reach out to myself. They'll reach out to Mist, and we can help you get started down the path.
Yeah, and anyone can email. We'll put a link there in the chat for info@mist.com, and we'll get back to you. So if you have any other questions, feel free to send them there, and we'll get you set up with everything that you need. All right. Thanks, guys. Appreciate you being here.
Thanks.
Thank you.